These notes are for the set of 4.9H. In that set, you'll be given some matrices and you'll be asked to perform some operations. So our first example, we're going to do A plus C. I'm going to rewrite matrix A, 3, 6, 2, -1, plus matrix C, -3, 8, 4, 11. When adding matrices, I'm adding the elements, the objects, in the matching spots. So I have upper left plus upper left, lower left plus lower left, upper right plus upper right, lower right plus lower right. And then I simplify. 0, 10, 10, 10. Our second example is A minus B. I start again by writing my A matrix, 3, 6, 2, -1, minus my B matrix, 5, 7. Here I have an upper left and an upper left, an upper right, and an upper right. However, this second matrix, B, does not have anything lower. I don't have a lower right or a lower left, where matrix A does. And so these cannot be added. And I just use that fancy symbol to say, can't be done. Third example, A minus 2C. So again, start with matrix A minus 2 times matrix C. In this case, this is called scalar multiplication, meaning I multiply everything in this matrix by 2. So, of course, matrix A stays exactly the same. And then I have 2 times -3, 2 times 4, 2 times 8, and 2 times 11. Still have matrix A. But now I also have matrix 2C, so -6, 16, 8, and 22. Just like in adding matrices, when I'm subtracting, I am still adding the elements that sit in the same spots. I'm just subtracting them now. So I have upper left minus upper left, lower left minus lower left, upper right minus upper right, lower right minus lower right. And then I simplify that. Our fourth example is we're going to do some multiplication. So we're going to multiply matrix B times A. So matrix B is 5, 7. And matrix A is 3, 2, 6, -1. When I'm multiplying matrices, I multiply my row to my column. You have done multiplying matrices in the previous section as a word problem. As I'm doing this work, you will notice that this is the same thing you did in 4.8. It was just that it was done in a context, and context can often be very useful. So if that's useful here, you can add a context, or you can go back and look at the previous problem. So I have one row here. We'll call it the top row. And so what I'm going to do here is I'm going to multiply my top row to my left-hand column. So 5 times 3 plus 7 times 2. And then I'm going to do my top to my right-hand column. 5 times 6 plus 7 times negative 1. And then we simplify. 15 plus 14, whoops, and 30 minus 7. So then my final answer is 29/23. My next example, I'm going to try multiplying A times B this time. So I have my A matrix, 3, 2, 6, negative 1. And I have my B matrix, 5, 7. Now, in regular multiplication, the order doesn't matter. So the question here is, does the order matter? So remember, I'm looking at a row and a column. So I have a top row and I have a right column. You'll notice that in my top row, I have 2 elements, 3 and 6. But in my left column, I only have 1. And so this can't be multiplied. I need things to match up. My last example is going to be A times C. So matrix A, 3, 6, 2, negative 1. Matrix C, negative 3, 8, 4, 11. So again, we're doing row, column. So top row, left column. 3 times negative 3 plus 6 times 8. Top row, right column. 3 times 4 plus 6 times 11. Bottom row by left column. 2 times negative 3 plus negative 1 times 8. Bottom row, right column. 2 times 4 plus negative 1 times 11. So again, top, left, top left, top right, top right. Bottom left, bottom left. Bottom right, bottom right. And then we simplify. Negative 9 plus 14, 12 plus 66, negative 6 minus 8, 8 minus 11, which gives us 5, negative 14, 78, and negative 3.